Welcome. Today we will be going over injection molding in this video. Here are some examples of some injection molded parts. See how they're very complex in their shape. We will be going over basic components, detailed animation demonstration, safety, how to operate VTP set point, examples, strength demonstrations, and works cited throughout this video. So, basic components and actions. We've got the hopper, which fills with resin or whatever material you're using, goes through the heater, which is moved by the screw into the mold. You've also got on the right side the ram, the hydraulic fluid, and the motor that powers the screw.
Once the resin pellets are loaded and digital instructions are programmed, the pellets move from the hopper to the barrel, where they're melted by heaters in the press. The ram and screw on the press work together to compress and inject the resin into the mold's runner system and through the nozzle to the mold cavity. After the cavity fills with resin, the mold opens and steel pins eject the thermoplastic part. Final parts are shipped in as fast as one day.
Operating an injection molding machine is quite safe. Obviously you have to wear your standard PPE and mind what you touch, as there's lots of hot objects. Okay, so now we will go over how to operate the injection molding machine using this video as a demonstration. So here's an example of the finished part they create throughout this video. So with operation, we begin with selecting the appropriate mold, and here is the example of the mold that they used to make that part previously seen. Now here's the machine. So in operating, you stand in front and control using the computer, and you put your granulated plastics or material into the hopper, which then go through the heating elements, and the screw injects the melted material as it moves along the screw. So now you can see that it's spinning the screw and proceeding the granular material into liquid as it approaches the mold, where it is then injected into the mold. As seen there, and we have to make sure we choose the right material and the right amount of heat to get the metal or the material melting at the right temperature for molding, which is then cooled through the cooling system in the mold. And throughout that process, you have to have the right calculation of material to heat to cooling ratio using the machine computer on the machine as seen earlier on the left side of this machine if it zooms out, and it's repeating this process a couple times as it is showing. So yeah, the operation is actually pretty basic because it's mostly computer controlled. You have to do a couple calculations for the heat, as I mentioned, and other than that, it's just timing issues that you program into the computer there on the left side, and that's how you operate.
A recording of screw travel versus time looks like this. The screw starts forward and continues moving until the mold is full. The screw stays forward until screw rotation starts. Then the screw returns to its starting point. We'd like to set the VPT set point to occur just as the mold is full. That would be slightly before the screw stops moving forward, about here. We could check this by making short shots. During injection, when the screw has traveled a distance set as the VPT point, the control system switches to pressure control to start the packing. Now we'll look at another possible measurement to use as the VPT set point. Some control systems use a hydraulic injection pressure measurement. A hydraulic transducer is put in the injection circuit to measure the oil pressure. In some molds, generally the easy-to-fill molds, there is a sharp rise in the injection pressure when the mold is full. If this point is apparent, it can be used as a VPT set point. If you're molding thin-walled parts, the hydraulic pressure may not show this break in the curve. The hydraulic pressure may rise too quickly.
fly, I think.
Yeah, I know. I feel like I'm kind of in the impact zone here. 165, 170.
All right.
Wow. So that's better than the than the
Yep, way
HTP.
better. We could stop if we're
No,
Stop for a sec.
just
sit at.
180,
All right. Already surpassed the HTP.
and it's barely deformed.
It's gonna
There it
snap.
goes.
What's it at?
198, 200.
Woo!
That whole shelf
I totally
is
flinched.
Yes. Perfect.
Fuck
So
yeah.
what did it go to? 200?
Is it 200? Yeah.
So
Wow.
way
fuck
better
yeah.
strength and much less deformation. That's amazing.
That's so
That's
cool,
cool.
man. So it's like basically better in every respect.
Yep. Yep. It's stiffer and it's stronger.